Hello, today we will be talking about the Bose-Einstein condensate. So what is a Bose-Einstein condensate? By definition, a Bose-Einstein condensate is a state of matter that occurs when a set of atoms is cooled to almost absolute zero, in which a statistical description of the position of the atoms implies that they physically overlap with each other and in effect form a single atom, sometimes called a superatom. This means that when certain types of atoms are cooled so much that they get close to 0 degrees Kelvin, or negative 173.15 degrees Celsius, the coldest temperature possible, at which atoms have essentially no motion, they start to merge and act as one large atom. The Bose-Einstein condensate was originally hypothesized by Albert Einstein and Satyendra Nath Bose after Bose wrote a paper to Einstein theorizing that the Bose-Einstein condensate would be possible. The Bose-Einstein condensate is the fifth state of matter discovered, and it was named in their honor. In 1995, Eric Cornell and Carl Wyman from the University of Colorado at Boulder, NIST JILA, created the first pure Bose-Einstein condensate using about 2,000 rubidium atoms at 20 nanokelvin, just a tiny bit above absolute zero. A short time later, Wolfgang Ketterle produced not one but two pure Bose-Einstein condensates, but instead using sodium atoms and using more of them. Ketterle let the two Bose-Einstein condensates expand into one another and combine, showing that they are made up of entirely coordinated atoms. Ketterle also made a small stream of Bose-Einstein condensate drops, which were affected by gravity and acted as an atom laser. These three, Eric Cornell, Carl Wyman, and Wolfgang Ketterle, won the Nobel Prize for Physics in 2001 for the achievement of Bose-Einstein condensation in dilute gases of alkali atoms, and for early fundamental studies of the properties of the condensates. As was said before, the Bose-Einstein condensate behaves as a superatom, but it also has some interesting properties, including that it can behave as a wave, be laser-like, and perhaps the most interesting, some can behave as superfluids. Bose-Einstein condensates can behave as a wave because they are made up of bosons. For instance, a photon, the boson that is a light particle, also acts as a wave, a principle known as wave-particle duality. They can also form atom lasers, as was demonstrated by Ketterle, which has several interesting theoretical uses that could possibly manifest in the future. One of the most fascinating properties of some Bose-Einstein condensates is their superfluidity. Superfluidity is a term used to describe the behavior of a Bose-Einstein condensate that behaves like a liquid as it moves. The liquid Bose-Einstein condensate generates no friction and is therefore able to go up the sides of a container with ease. There have been many tests done on the Bose-Einstein condensate, and recently there have been several tests in space using NASA's Cold Atom Laboratory, as the Bose-Einstein condensate can last significantly longer in space. The Bose-Einstein condensate is certainly a very interesting state of matter, and there will be more further research on the state in the future, and perhaps the Bose-Einstein condensate will be more widely used in the future in practical scenarios. Thank you for watching, and if you have any questions or comments, please leave them below, and have a great rest of your day.